Today we're looking at Geometry Chapter 3, Section 7, Constructing Points of Concurrency. Points of concurrency, when a set of lines has a point in common, they're concurrent. Segments, rays, and even planes are concurrent if they intersect at a single point. So you can see these three lines are concurrent because they intersect at a single point. All three of these lines are not concurrent because they're not intersecting at a single point. So what we're going to be doing is we're going to be looking at the concurrency of triangles. And we're going to review some of our constructions. So an angle bisector, let's refresh our memory on that. So to do an angle bisector, we create an arc. Then from where those arcs intercept the lines, I create an arc that is in the middle here of the angle. The other point, I do the same. And so now I can see where those intersect, and I've created an angle bisector. Perpendicular bisector. So let's look at the perpendicular bisector. So a perpendicular bisector. So what we do is we go at the end point. I go a little bit past the middle, and I make a big arc above and below, and then I repeat that on the other side. And what I've created is a perpendicular bisector. It's perpendicular, and it also cut the segment in half. Perpendicular through a point is very similar to that. What we do is we start with the point of rotation on the point, and then I get my compass so it's just past the line. And then I make an arc so it intercepts it at 2 points. Where it intercepts, we then draw an arc below it. Same thing, arc below it, and that gives me my perpendicular through a point. So here, this is perpendicular. And midpoint, to create the midpoint, is actually the same thing we did earlier. We're actually going to define the midpoint by doing the perpendicular bisector. So I'm doing the exact same thing we did on a perpendicular bisector. Now the reason this is going to give me the midpoint is because perpendicular bisector bisects the segment into 2 congruent segments. So that is how I create the midpoint. So the angle bisectors of a triangle, you notice, look, they intersect at a single point. The angle bisectors is called the incenter. That's called the incenter. The perpendicular bisectors also intersect at a single point. The perpendicular bisectors is called the circumcenter. The circumcenter. The altitudes of a triangle, remember the altitudes of a triangle are from the vertex to a point that is perpendicular to the side of a triangle, even if it's outside the triangle. And you'll notice, look, all 3 altitudes intersect at a single point. The altitudes are called the orthocenter. The orthocenter. And then last, the medians. The medians, remember that's the midpoint of each segment, of each side. The medians, again, they intersect at a single point. The medians is called the centroid. So all 4 of those constructions intersect at a single point, and they all have those particular names: the incenter, the circumcenter, the orthocenter, and the centroid. Let's do a little bit of algebra review. We're going to factor the following problem. So x squared minus 9. There's no x. There's an x squared. So I got to think about this. This is going to be x times something, x times x plus something, x plus something, or x minus something, so forth. So 9 factors into, negative 9 factors into 3, negative 3. And there we go. Now, if you want to double check to make sure that this works, let's FOIL. X times x, it's x squared. X times 3 is negative 3x. 3 times x is positive 3x. 3 times negative 3 is negative 9. And look, negative 3x plus 3x, they disappear. So it works, x squared minus 9. And let's factor this problem. It's the same idea. Now notice we have 4x. I'm actually going to go ahead and split this up into 2x and 2x. I'm going to do the same thing. Negative 25, well, let's think about that. That splits up into negative 5 and 5. And there we go. There's its factor. That is the end of this lesson.